Good morning, everybody. Welcome back to Math 105. Y'all had a good weekend?
Yeah.
How can you tell if a mathematician is an extrovert?
He gives you his number.
Did you get what?
He gives you his number.
No, that's way too out there for a mathematician. No, you can tell if a mathematician is an extrovert if when they're talking to you, they look at your shoes instead of their own. Give you their number. That's, whoa. I've never seen a mathematician do that before. Okay, so the plan for today is we are going to finish our discussion of Standard 3, kind of finish our discussion of connectives, the and or statements, which we introduced last time. Upcoming office hours are the usual ones for the next few days. Today, Wednesday, at 10 o'clock and 2 o'clock, there'll be office hours. And on Tuesday, or tomorrow, I'll have an hour and a half in the morning and an hour at 1:30 in the afternoon. Upcoming assignments. Standard 2. The quiz for that is due tonight, as a reminder. I haven't posted it yet, but I'm going to post it later today. The Standard 3 quiz will be due on Wednesday night. So I'll have a couple days for that. A few comments about quizzes. You may have noticed over the weekend, if you checked your email, I graded things. So I graded all the Standard 1 quizzes, as well as all of the Standard 1 retest and Standard 2 quizzes that had been submitted to me by 4 something yesterday. 4 o'clock-ish yesterday. Yeah, I need to play around. I hate Blackboard. I'm so glad the school's changing to a new learning system because I've never used Blackboard in the past except for very simple things like, here, let's post files. And Blackboard, I think, works fine for that, so I've always been happy. This semester has taught me that trying to do like quizzes and such through Blackboard will fight you every step of the way, which is why. Sorry if you email me noticing that like it says I got a mastery on this, but my score was 0 out of 10. I screwed up making the options apparently for this quiz, for the quiz 1 and quiz 2, and it required that I enter a score for you out of 10 or 0 or whatever. I'm going to try and do since this class is not based on getting scores like that, it's based on did you get the mastery or did you not. I just left everything as a 0 because that was the easy default for me to do. So don't freak out if you got a 0 out of 10 on something. That doesn't mean you're a complete failure. That means I am a partial failure at navigating the intricacies of Blackboard. So what you should do instead is there is a feedback to learner thing. I left you your grade there. Either an M for mastery, or a J for journeyman, or an N for novice. And again, getting an M for mastery is the only one that gets you the mastery. The others just don't affect your grade at all. I think I tweaked with some options before class that should let you, apparently you couldn't actually, okay, question. Were any of you able to see individual question feedback? Okay, I thought so. Got a couple emails about that last night, went in this morning. I think I tweaked it, so you might be able to see that now. Because I did write individual feedback for every question that you answered. The feedback might be as simple as yes, if I agreed with everything you said. But if I disagreed with something, I left you a little bit more detailed comments. I'm hoping that you can go in and see that now. I had to go and click a box that wasn't clicked. Because apparently when I grade things, you can't see the grades or you can't see individual question feedback unless I click this box. Makes no sense to me. So we should be able to see that now. It's annoying because I can't really tell what you can and can't see, but hopefully that's the thing. Gradebook. S1 through S20. Those are the only things showing up in your grades that you should care about. Not your individual scores on like Standard 1A, Standard 1B, Standard 2A. Because again, I'm just going to give you zeros on those. What should matter is the amount of masteries you have, and that I will keep track of as a score out of 2 for S1 through S20. And that is the only thing that matters for you as far as your grade is concerned. I will play around with Blackboard some more and hopefully streamline this a little bit for future quizzes. But it is a learning process for me. Any questions about sort of quizzes or feedback or anything before you get started for today? Okay, in that case, let's talk about connectives. So you might remember that connectives were words like and or that allow us to combine two mathematical statements into a single one, to a compound statement. And given two statements P and Q, we said that the statement P and Q, where and, the symbol for and was this little, whatchamacallit symbol, arrow pointing up. We said that P and Q is true if both P and Q individually are true. And if at least one of the two individual statements is false, then we said that the and statement also had to be false. Even if one is true and the other is false, P and Q is going to be a false statement. And our Venn diagram, if the circle for P is whenever P is true and the circle for Q is whenever Q is true, P and Q is only going to be true in the overlap here. The overlap of where P and Q are both true. On the other hand, we had or statements, P or Q, or this time it just looks like a little V pointing down, which we said the or statement is going to be true if at least one of P and Q is true. So if either just P, just Q, or if both P and Q are true, all of those would be circumstances under which the statement P or Q is going to be true. And the only way for an or statement, P or Q, to be false is if both P and Q turn out to be false. So here, if we look at our Venn diagram, if we're in the circle for P at all, or if we're in the circle for Q at all, the circles for P or Q are true, then P or Q is going to be true. And the main difference between an or statement and an and statement, both are going to be true if P and Q are both true. Both are going to be false if P and Q are both false. But if exactly one of P and Q is true, let's say P is true and Q is false, then the and statement is going to be false, whereas the or statement is going to be true. And so last time, we were looking at a few different statements, a few different mathematical statements about where I gave you some statements about Jimmy. P was the statement that Jimmy bought ice cream. Q was the statement that Jimmy ran to the store. R was the statement that Jimmy played video games. S was the statement that Jimmy played football. And finally, T was the statement that I am 32 years old. And if you recall, we had left off looking at the statement not S and not R, which you all said was the statement that Jimmy didn't play football and didn't play video games. And our goal, what we were in the process of doing at the end of class, was to try and negate this statement. In other words, we're negating the entire statement, not S and not R. And since we have a negation in front of big parentheses surrounding all of not S and not R, that tells us we're trying to negate this statement right here. Yes?
Last time people were trying to distribute the negation and make it look like a negative. Can you just say it's not true that Jimmy didn't play football and didn't play video games?
It is not true that Jimmy didn't play football and didn't play video games. English professors are twinging in agony right now with that triple negative. You could say that. It is not true that Jimmy didn't play football and didn't play video games. That would be a way to negate this. It's a way to negate it, though, in a way that I don't feel, in a sort of confusing way, I would say. In a way that's sort of, what does it mean to have it not be the case that Jimmy didn't play football and didn't play video games? Is Jimmy playing football or video games? Hard to, or playing video games? A little hard to tell from a statement like that. So while it's true, not necessarily the most helpful of statements.
How about Jimmy played football or Jimmy played video games?
You made it an or statement. Why is that?
Because
other than the fact that I said that's what I said at the very end of class.
yeah, what you said made me think about it. And but if you look at the statement, in order for you to rule out the possibility, if you use another and statement to negate it, then it leaves room for one of them being false. So then both statements could be not true at the same time, which would mean it wouldn't be the negation of it. So if you use another and statement, then both the positive and the negative could be false at the same time. But if you use an or statement, then it means that you have that possibility for one side being true and the other side being false, which doesn't leave that room in the middle for. I know I'm explaining it in a confusing way.
No, I think you're doing great. I think this is a confusing thing to try and explain, and you're doing a good job with it. Yeah, so here I think it can be very helpful to write out a Venn diagram for something like this, because we're trying to negate something that already has two negations in it already. So I think it's helpful for something like this, and I think you were absolutely spot on with your reasoning. It comes from the fact that if we're trying to negate a situation where two things aren't happening, we have to allow for the possibility of just one of those things happening, which would be one opposite scenario. It's a little bit hard to kind of wrap my mind around, I think, something like that, unless I have a picture maybe to look at. So let's see if we can draw a Venn diagram for what Jimmy's doing here, and then see if we can draw the opposite Venn diagram for what Jimmy's doing with this statement. So here, let's say this is the football circle, the circle where Jimmy's playing football, and this is the circle where Jimmy's playing video games, or played. It's all past tense, I suppose. What should we actually be filling in on our Venn diagram if we're saying Jimmy didn't play football and he didn't play video games?
Everything that's not inside of the circles.
Yeah, we're not in the football circle because Jimmy didn't play football. We're not in the video game circle at all since Jimmy didn't play video games. What we need to actually fill in on our Venn diagram is going to be everything outside of the circle. Everything that encompasses all the possibilities where Jimmy is doing neither of these two things. I sort of made a couple of flowers or something. So what we're shading in for this statement, not S and not R, is going to be the scenario where we're outside of both circles. Not including any of the football circle, not including any of the video game circle, and we're certainly not including any of the overlap. So now, we're trying to negate that. We're trying to find the negation, so to speak, of this Venn diagram. And if you notice, when you think about a Venn diagram like this, where the Venn diagram is shaded in is where the statement it refers to is true. And anywhere where the Venn diagram is not shaded in refers to where the statement it's referring to is false. So in this case, the football circle and the video game circles are not filled in. That's because if we're in either of those circles, this statement is false. When you try and negate a statement, if you use the Venn diagram, you can do that by shading in on the Venn diagram of the negation, shade in everywhere that this diagram wasn't shaded in, and leave blank here everywhere that this was shaded in. So if we sort of flip the shaded in areas and the non-shaded in areas, what's going to be filled in on the Venn diagram for this one?
Everything in the circles.
Everything in the circles, including the overlap? I agree. Yeah. So here, we're not filling in, it's everything outside the circles. Here we can fill in everything inside the circles. And if we fill that in, what does this look like the Venn diagram for?
Oh, I was gonna say that one.
This one?
Yeah.
Yeah, it's the Venn diagram for a positive or statement. And so I think kind of using Venn diagrams, you can arrive at the same answer and say that this is going to be logically equivalent to the statement S or R that Jimmy played football or played video games. What's that symbol? Anyone seen that before? Kind of a fancy symbol. We're saying somehow that these mathematically appear to be the same sort of statement. What was our term that we used last week for two statements that mathematically behave the same way?
Logically equivalent.
Yeah. So this kind of double arrow symbol, which you might see like that, or you might see written out from left to right like this, that's just a symbol that means logical equivalence. So, while it certainly would be true to say we could write out not S and not R as meaning it is not the case that Jimmy didn't play football and didn't play video games, it would logically be equivalent to say Jimmy played football or video games. And to me, I like that second one better just because it's a lot more clear to me what that second one is saying. He played football or he played video games. Potentially both. Whereas he failed to not play football and not play video games. Takes a lot kind of more mental unwrapping. What does that mean? If I asked on a quiz something like, write this statement out in words, you could theoretically say, I would accept Jimmy failed to not play football and not play video games. However, I'm likely to ask that question on a quiz, saying something like, use no more than one negative in constructing your answer. And in that case, you would need to kind of be able to pare it down to something like this. Questions, comments? Yes?
Would it still be okay if you simplified down the double negative and statement? Like if you just said Jimmy played football and played video games?
If we had said if we had simplified this one down to Jimmy played football and played video games, what do you all think? Would that be okay?
If you think about it like a Venn diagram, if you use another and statement, you look over there, see which part is shaded in. It's only the overlap, the middle. So that doesn't account for the rest of the two circles that need to be shaded in to negate that. So So an and statement doesn't account for the rest of that, that and or that could happen. So if Jimmy only played football but didn't play video games, that would still negate that other statement. But if you use an and statement to negate it, it doesn't account for that possibility.
Yeah, I agree. I think the problem with the and statement is one way that this statement could be false is if Jimmy played exactly one of football and video games. Let's say he played football but not video games. So if you tried to negate this by saying Jimmy played football and video games, if we're in the scenario where he only played football, this one would be false. But the played football and played video games would also be false. And so I don't think that would quite work as a negation. One thing to keep in mind is there's several ways you can write the negation here, but they all need to be logically equivalent to each other. And Jimmy played football or video games is not going to be logically equivalent to Jimmy played football and played video games. Everybody? Okay, let's do these last two on this page really quick before we move on to talking about negation of or and statements in general. How about this one? T and not T.
Dr. Gerstle is 32 years old and is not 30 years old.
Dr. Gerstle is 32 years old and isn't 32 years old. Whoa. I don't think that statement's ever going to be true regardless of what my age is. And finally, if we were to negate T or not T, how could we negate this one?
Dr. Gerstle is not 32 years old, or he is 32 years old.
Ah, so it sounded to me like you tried to take an or statement and negate it with another or statement. So you said Dr. Gerstle is, I'm sorry, can you repeat what you said?
Dr. Gerstle is not 32 years old, or he is 32 years old.
We're going to leave off the years old because it's not really adding anything. Dr. Gerstle is not 32 or is 32. So something sinister is happening here, in that we're negating a compound statement again. When we negated this compound and statement, it ended up turning into an or statement. Hello.
Hello.
It's also going to be the case that if we negate an or statement, it's actually going to turn into an and statement.
Except that was an and statement.
But we weren't negating the whole compound statement in this case. If we had parentheses around the full thing and then a negation in front of that, then we would be negating a compound and statement, which would turn into an or statement. But here, we weren't negating the and statement. We're just writing an and statement that happened to involve the negations of one of the two individual statements. Which is, it's a very subtle distinction, but it is a distinction nonetheless. So I don't think this quite works.
It's not true that Dr. Gerstle is 32 years old and isn't 32 years old.
It's untrue that, repeat.
Dr. Gerstle is 32 years old and isn't 32 years old.
It's untrue that Dr. G is 32. I would say or isn't 32. Because if you want to just negate the whole thing by just saying out front, it is not true that, then whatever is coming true, you write after it is untrue that Dr. G is 32 or isn't 32 should just be the same as the piece that's inside of the outer parentheses. Because negating something within these outer parentheses is going to be the same as saying it is untrue that. Does that make sense?
It's like I am not true or those things.
It's a weird sentence to say, for sure. So, I gave you some, I wanted you to think about this a little bit over the weekend because I think these are some harder statements to negate. But I'm going to go back now that we've kind of seen how can we do it with Venn diagrams, and we can look and see how can we sort of do it by thinking logically through the different scenarios. And this is going to give us a general rule for how can we negate an and statement, how can we negate an or statement. Because so far we've seen some examples where we negate it with throwing an it's untrue that or it is not the case that out in front of everything. We've also seen ways that we can negate using these sorts of Venn diagrams. I also like to think about what does it mean to negate a statement by just kind of thinking through the different scenarios that can be occurring. So let's see if we can do that. Thank you, Jimmy. You did your job well. So I'm going to flip the page now. And next up, I want to look at the statement, China is in Africa. And Brazil is in Asia. So we're given an and statement, and we're asked to negate it. And I'd like to try and negate it in a way that doesn't involve just saying it is not the case that China is in Africa and Brazil is in Asia.
It wouldn't be any double negatives, though.
It's true, it wouldn't be. In fact, the way I have in mind is going to negate. But it is negating in a somewhat unsatisfying way in that we're just throwing in it is not true that in front of the whole statement, and it doesn't tell us what does have to be true or false. It's just saying it's not the case that compound statement. Sometimes it's nice to be able to say individual things without having a negation just in front of some compound thing. Yes?
China is not in Africa or Brazil is not in Asia.
China is not in Africa or Brazil is not in Asia. I like it. Do you mind explaining your thought process?
Well, when we have an and statement, it is false if one of them is false. Although we know geography from a strictly logical sense, we don't necessarily know which one is false, so we just have to say that one of them has to be, hence changing it to the or statement.
Yeah, we know an and statement is true requires that the individual pieces, P has to be true, and Q also has to be true. So if we want to negate that, if we want to look at what does it look like to say we're in a scenario other than P is true and Q is true, that comes from the scenario where at least one of the two individual statements are going to be false. Because that's when we said an and statement is false, is if at least one of the two individual statements is false. The opposite of both being true is not both being false, because that doesn't account for what if one is true and one is false. The opposite of both being true has to be this scenario where at least one of them is false. In a way, we could write that out as a compound statement. At least one of P and Q are false is using an or statement. The P is false or Q is false in this scenario. which yes, is logically equivalent to saying it is not the case that China is in Africa and Brazil is in Asia.
Awesome.
Here's a good quiz question. Find two logically equivalent ways of writing the negation of this statement. And then you could say it is not the case that blah, that Brazil is in Africa, China is in Africa, Brazil is in Asia? Well, that is how I wrote it down. Meant to write it the other way. Doesn't change anything. But negating the scenario where both P and Q are true is going to be giving us a scenario where at least one of the two statements is false. How about this one? Dr. Arndt eats bad students, or pennies are made of gold. This is going to be our statement P. It's going to be our statement Q. And now we're looking for a way that we can negate this or statement. The statement that's going to be true if at least one of the two individual statements is true. What would be a way that how could we negate at least one of these two statements being true?
Dr. Arn does not eat bad students, and pennies are not made of gold.
Yeah. The way we negate an or statement, where an or statement is true if at least one of them is true, we negate that by saying, let's put us in a scenario where both of the two individual statements are going to be false. So our negation is going to be Dr. A doesn't eat bad students. In other words, the negation of P and pennies are not made of gold, including Dr. Arndt's wife. If we wanted to, we could try and visualize this process through Venn diagrams by saying, here, with the original statement, we're in an and scenario, so we're shading in all of just the overlap between P and Q. What would the negation be if we were to negate a statement that has this Venn diagram to it? What would the Venn diagram look like for the negation? If we leave blank anywhere this is shaded in, and shade in anywhere that this is blank. What would the Venn diagram for that look like?
Shaded everywhere except for the very center.
Shade in everywhere except for the very center, including the outside as well. So the negation of this and statement is going to consist of every possibility except for the one where they're both true. And that's going to correspond to a statement where at least one of the two statements are not true. Potentially both. In a similar way, if we were to draw a Venn diagram for this statement, our or statement, here's our P, here's our Q. The or statement is going to be shaded in like this. How do we negate that? What would be shaded in the Venn diagram for the negation?
Everything outside the circles.
Everything outside of the two circles. So, and outside of the two circles here is the same as saying P is not true and Q is not true. That's the only way to be outside of both of the P circle and outside of the Q circle simultaneously, is if first is not true and second is not true. So now, I'd like to give you all a couple minutes. I give you this very similar sort of situation at the bottom of the page. But instead of giving you two specific statements, I'm giving you two general ones that just involve these symbols, P and Q, P or Q. So I'd like for you to take just a minute and see if you can negate the two statements that are just using symbols, where P and Q could correspond to any statements. You don't know what they mean. Let's go ahead and take a minute and see what you can make of those. So if we're trying to negate the statement P and Q here, what would be the way that we could write out the negation of that?
I have the actual answer, but you could also put it untrue that
Yes, you could just throw parentheses and slap a negation symbol out in the front, and that would technically be correct. You can stop calling on you.
negation of P or negation Q.
Like that?
Yeah.
So you're going to say?
Wouldn't it be and negation?
Well, let's think about it. I think it's going to have to be an or statement for the same reason when we negated this and statement, it ended up being an or statement. Because if we're trying to say we're not in a scenario where both P and Q are true, that just means at least one of them has to be false. It doesn't necessarily have to be the case where both of them are false, which would be the scenario where you would say not P and not Q.
Yeah.
Okay. So if we wanted to, though, yes,
I just had a question.
before.
So is it always going to be true that the negation will always be the opposite sign? Is there ever a point where and can negate and?
No. Yes, but that's extremely technical, and we're not going to encounter those scenarios in this class. That would be if we had sort of like an infinite number of or/and statements built into one. And we're not going to do that. So, if we wanted to, we could say another way that we could write this would be to say the negation of P and Q. And these would both be logically equivalent ways of negating the statement P and Q. But if we wanted to negate the or statement, P or Q,
Negation of P and negation of Q.
like that? I like it. Same sort of thing that happened in this Dr. Arn and Penny scenario. That here we started with a P or Q statement, and when we negated it, we ended up with a not P and not Q sort of scenario going on. Which would also be logically equivalent to saying it's not the negation of P or Q. So this, to be clear, would be the cheeky sort of, it is not the case that P or Q is true. Whereas this would be, P is false and Q is false. Would be the way you would kind of read these out loud. You'd read them out loud in slightly different ways, but they are logically equivalent. Which again means that when we say logically equivalent, we mean if this compound statement is true, then this one has to be true, and if this one is false, then this one also has to be false. Questions or comments? Okay, in that case, I'm going to give you the opportunity to kind of look through the next page on your own. We're coming back together as a class.
Next Q or
Just the next one for now. If you finish, go ahead and go to the second, but we're just going to talk about the next page. I don't think we're going to have time to get to the last page of this. So, there exists an octopus and there exists an alligator. All lines are straight or no lines are straight. Not P and not Q. P and Q and R. I want for you all to take a couple minutes and see if you can try negating these statements.
I have a different one for the second one. Is that okay? It says some cows may or no cows may grass.
Dang it. I thought I fixed that. Go with the one version you have. Sorry, I edited this to change it, but I guess I edited it after I printed it. I was before. The first couple here, you have to think about how you kind of combine standard 2 and standard 3 type question in that we're having to negate a compound statement that involves quantifiers showing up. As always, if you have thoughts and you feel comfortable doing so, you can share with your neighbors. Make sure you're wearing your mask if you do so.
I just kind of simplified it to negation piece or negation piece function of power.
So what did you all think about this one? There exists an octopus and there exists an alligator.
No octopi exist or no alligators exist.
No.
Octopi?
Octopi, that doesn't sound like a real word.
I think that's the plural. I use them all.
Actually, I think the plural is technically either octopuses or octopode.
Oh,
This
well.
is an English class.
English version is wrong. Octopus is one of those irregular words.
Not one octopus exists.
Not one exists. I'm using octopuses. No octopuses exist. And what was the second part?
Or no alligators exist.
Or no alligators exist. Everyone on board with that? Yeah, I like that. So this one was tricky in that it had quantifiers, two quantifiers, well technically same quantifier twice, built into an and statement. We said that the negation of P and Q was not P or not Q. So not P in this case, we're negating there exists something, and the negation of there exists is none exist. So no octopuses exist or no alligators exist. I like it. How about this next one? Some cows moo or no cows eat grass.
At least one cow does not moo, and some cows eat grass.
At least one cow doesn't moo, and
Some cows eat grass?
some cows eat grass.
It should be no cows moo though, because some cows doesn't count for at least one cow not moo.
Yeah. I think you negated the compound part, right? You negated the compound part from taking an or to an and. But I think the negation of some cows moo ends up being just no cows moo. Because some cows moo, which is the same equivalent to saying at least one cow moos, the negation of that is there are no cows at all that moo. Or moo. Moo. I'm mooing myself already. So here, when we negate these sorts of compound statements, not only do we need to correctly negate the compound part, and becomes or becomes and, but we also need to negate each of the quantifiers that show up. How about this one? Not P and not Q.
P or Q.
P or Q. Technically, if you wanted to, you could be cheeky and say not P or not Q. But that's just another logically equivalent way of saying P or Q.
Or you could just say not P, not negation of P and negation of Q.
Or you could say not P and not Q. And instead of, well, actually, I guess that is fewer negatives in this one. Then not P or not Q. Here, I think it's important to use parentheses to make sure it's very clear what you're negating. In this case, this negation is just negating the not P, whereas this negation is negating the entire compound statement. But these would be three logically equivalent ways of all negating the same thing. I like P or Q the best because it's the simplest. It's the one that requires the least amount of thought, at least to me, to understand what it's saying, if I were to try and draw a Venn diagram based off of this. I know what the Venn diagram for P or Q looks like. I'd have to stop and think a lot about what does the Venn diagram for not P and not Q looks like. And finally, P and Q and R.
Not P or not Q or not R.
Bingo. If we have multiple ands built in like this, then the way we would negate that is by just making it a giant or statement. So we could say not P, or not Q, or not R. If it's not the case that all three of P, Q, and R have to be true, that just means at least one of the three has to be false. And we can get that with a double or statement like this. Okay, that's going to do it for this standard. The back page has a few extra questions where I kind of give you a few statements, ask you to negate again. I'll post solutions later today, and I encourage you to talk more with me if you have any more questions. On Wednesday, we're going to talk about how to negate if-then statements. It's kind of the last type of complicated statement we're going to be looking at before we move on to some other topics other than mathematical statements. Have a good day, y'all. Yes, that would work because this part is the same as saying not P or not Q.
Yeah, so it just says you didn't have to go it's not.
In this case, it's clear. It's
Well, no, wait, if I did that, wouldn't this, if I did this, wouldn't, oh no, you don't have to.
You could have parentheses here, but it wouldn't change anything.
Oh, okay,
But yeah, these are logically equivalent mainly because this first piece right here is logically equivalent to that right there.
okay, got it.
Ah, good, nice, thank you.
Dr. I just want to apologize for being late. Neither I or my roommate's alarms went off this morning by some freak of nature. We both decided.
Funny how that happens.
I know. So
I've been there, no worries.
yeah, we always get up at the same time too. So we both like woke up panicked.